of the most common test methods performed in MIL-STD-461 is RE102. This evaluates the radiated electric field emissions measurements produced from the device under test, really from the device chassis as well as its associated cabling. Tests here are performed from 10 kilohertz to 1 gigahertz, or 10 times the highest operating frequency used by the device, up to 18 gigahertz. RE102 doesn't require testing above 18 gig at this time. However, it is common to see test requirements beyond 18 gig, for example, up to 40 gig for special projects or space applications where high frequency communication signaling is used. RE102 emissions measurements are made at a distance of 1 meter from the UT and cabling. The requirement here is that the radiated emissions measurements are conducted over the entire surface area of the UT and a specified amount of interconnecting cable. RE102 defines how to accomplish this based on measurement frequency. So below 200 megahertz, the test setup boundary length, including the EUT and cabling, shall be divided by 3 and rounded up to the nearest integer. Therefore, if the test setup is less than 3 meters in length, then only one antenna position would be required. Now, between 200 megahertz and 1 gigahertz, the surface area of the EUT plus the first 35 centimeters of cabling that interconnects with the EUT must be measured within the receive antenna's half-power beam width. Then above 1 gig, the surface area of the UT plus the first 7 centimeters of cabling that interconnects with the UT must be tested within the antenna's half-power beam width. For those of you that are not familiar with the term half-power beam width, this is a parameter that is defined as the measurement area at which the measured power level is within 3 dB of the peak measured on either side of the receive antenna's center line. This is generally provided by the antenna manufacturer as a curve, as you can see here. The directivity of those antennas and beam widths are mainly driven by inherent design and given frequency. For frequencies above 200 megahertz, directional antennas are used such as a double-ridged horn or a standard gain horn. Generally speaking here, as frequencies increase, the antenna beam width will narrow. Therefore, the narrowest beam width value shall be selected for a measurement range in order to maintain that half-power beam width measurement requirement. Where EUT cabling and setup is larger than the receive antenna's half-power beam width, additional antenna positions will be required. So here, the data is compared to the appropriate limit or limits based on the installation platform and procurement agency. In some cases, such as surface ship applications, the RE102 limit may change based on where that equipment will be located on that platform. So for example, in a below deck environment, the EMI control limits are higher than the above deck limits in particularly exposed below deck environments. This is intended to reduce the potential interference with above deck communication receivers. It's also important to be aware of these differences, especially when you have products that could be used or expected to be used installed in different platforms. And in this example, in both above deck and below deck environments. So due to the 20 dB difference in control limits for these locations, you could end up with a device that easily meets the below deck emissions criteria, but exceeds the above deck's criteria in this case. Additional EMI mitigation and hardening would be required in order to reduce the produced radiated emissions and meet both limits.